Hi, and welcome to a lesson on web servers and HTTP for Web 2. Now, we have seen some Node, we have coded in the backend, but of course, running a persistent web server takes some more knowledge and takes some more coding to achieve. So, let's start with what a web server actually is. So, a web server, its sole job is to host a website. It mostly hosts it on hardware either in the cloud, of course, or on a local server farm. That hardware runs specific web server software. So either an Apache, an ISS, something like that. Also, mostly your source files for very simple websites are hosted on that server. So your HTML, CSS, your assets like images and JavaScript should be on there. Now, of course, you can run software on that hardware, and one of the main purposes of a web server is to have at least an HTTP server. So it handles all the HTTP requests. So remember when you did a fetch call to the Pokemon API or the Star Wars API or any API in particular, there is some code or software on the server side that catches your fetch request, reads it, and then does the accordant job associated with that request. If you're getting all the Pokemon from the first gen, then it will extract that from the actual fetch call, from the URL, and then do something with it on the backend. It will send a response back to you with either a data, an error, or something else. Now, different servers can have different purposes. They can be run by different software systems. So, for example, a file server can mostly function as a server that does FTP requests, so file transfer protocols. So you can have software that only does that. It can also be in addition, of course, next to an HTTP server, there can be an FTP server as well. Some servers also host their databases on that same machine. Now, this is not only the case for small websites, sometimes for bigger as well, but in theory, for larger systems, the database and the HTTP server are mostly separated, and they make connections through connection strings and specific IPs and connection data. Now, for our case, we will have our database in the cloud, for example, Mongo Atlas. So on our web server, there will not be a database on there. And of course, an application server if you need that. Now, for our example with Node, we won't need that. For in the PHP case, then of course you need to render your pages server side. Now, that's not the scope of this course, but keep in mind that if you're running a PHP web server, there's going to be some more details and some more knowledge needed to get further along. Now, imagine we make a request to your backend. Say that we have a login button when you log into a certain service to go to your profile page. Now, the frontend makes that request to the backend. The frontend is the site you are running on your machine, on your PC, laptop, iPad, iPhone, cell phone, whatever. The site that the user sees. That frontend, when you press the button, will send some sort of request, an HTTP request, of course, to that server. The backend, being the server, it handles the request. It executes some custom logic, so in the sense of logging in, it will probably verify your username, email, and or password. With that custom logic, it will get some resources. It will either connect to a database to verify that. It will look at its own files if it's on the same system, or make a connection to a totally different system. So in this case, for our login button, it will compare data from the request with the login credentials in the database. Then, depending on the result of that check, it will send back a response to you. It either be an HTML file, if the site is server-side rendered. It could be a JSON data that says, hey, it's okay, you can log in, and then the front end needs to handle all the rest. It can be even a script. It can be all kinds of things. But it sends a response back. Now, before we dive deeper into the request flow, I think it's important that we know how the HTTP requests work. So, HTTP, Hypertext Transfer Protocol, is a communication between a client and a server. So in our most use case, it's the client being the website that you're visiting, and the server is the one that's running on the server. Could be an API or could be an application server. We send the request from the client to the server, and we receive a response from the server to the client. Now, two major things you need to understand for HTTP request. It's that they have no connection. It's not like in a video game where you need to have a constant connection to a server to be able to play. No, an HTTP request is sent to a server, and that's it. There is no connection to be open to hold open. There's no connection to be had. It just sends it, and if it gets something back, that's good. But if it doesn't get anything back, well, that's it. That's the end of the line. So there's no open connection between client and server when you are shooting an HTTP request around. Now, there are different technologies when we're talking about live client-server relationships, WebSockets, for example, but that's not this. HTTP is a very older protocol, and it powers the whole internet in that way. So sending a fetch request and getting a response is all done without a connection. Now, the second point you need to understand is that there is no state. What do I mean by that? Say that you are asking for the first, let's say, the first 150 Pokemon from the Pokemon API. You send that request, the server gets it. They ask for authentication. They say, okay, it's Mike. I have a key here, and you're authorized, so I will send you the 150 Pokemon. My next request will be, you know what? Give me the next 100 Pokemon from the next generation. And I don't pass along my authentication because I already made a request. Why should I authenticate myself again? Well, this is very important. The server itself does not contain the state thanks to the HTTP request. It does not remember between requests who made the request unless there is specific code written by a developer to capture that. But generally, HTTP requests, like 10 of them in a row, they have no saved state in between. The fifth request does not know who made the fourth, the third, the second, and the first request. There is no state to be had on the server unless you code for it. Now, a very easy example of this would be indeed that on the right side we have our browser. We make a request to the web server that comes in. Our HTTP server catches this, and based on what we need, it grabs a file and it sends it back to an HTTP response. Now that we know what HTTP requests are used for, now the content of a request is also quite important to know. So a request itself, it needs to contain at least two things. It needs to contain a request line. We have 8 different methods possible. We will come to that in a second. So the sort of request. Most of you already know the get and the post. We'll get to the other ones in a second. And a header. So sometimes you need to pass along headers that determine language, the browser you're surfing on, the client encoding, cookies if you're logging in again with similar info, and of course domain info from where you are coming. Remember that nasty CORS error? Well, headers have everything to do with that, to say where you're coming from and of course what the server allows. These are needed to make a valid HTTP request. What is not needed but can contain is a body. You can add extra data to the server. So for example, if you want to save some content, you need to save that in mostly the body of the request, if you want it to be secure at least. And those are mostly done by post and put requests. So you've already heard about get and post, and now you see put. What are those request methods? Well, we have a couple of important ones that are mostly used for general CRUD applications. So CRUD, create, read, update, and delete. So a couple of them. Get is mostly used for retrieving data. The data that you pass along, if you want to pass it along, is located into the query string. And the query string means in the URL itself. So let's say you move to www.google.com, question mark, and everything after the question mark is data that is readable by anyone with that URL and can get retrieved by Google itself when the request comes through. There is no content in the body, or it should not even be in there. So get request, the data is visible in the query string. So the best use case of a get is that it should only be used to retrieve data. Now, head is not one you've used before. It is like a GET request, but it doesn't require a response body. It's mostly used to test out if a server is available, to test out the type of server, just to get a request back, but it will not give you data. While a GET, if you say, I want all the 150 Pokemon, it will send a response with some headers, a code, for example, and then a body with, of course, the 150 Pokemon you just requested. Now on to the next one is a very important one, of course, the post. The post, there, the data is saved inside the body. That means that it cannot be read by general means, cannot be viewed from the URL, but it's saved inside the body. And if you go through HTTPS, the secure version of it, then it will be encrypted as well. So the most safe way to pass along data in an HTTP request would be in, of course, an HTTPS connection and through a post request, because the data is in the body and it will be encrypted. A put is about the same as a post, but it's mostly used for updating or creating based on the data in the body. There are some use cases for that as well. Put is, in general development terms, mostly used for updating data. And a delete, well, I think that speaks for itself. The data that you pass along in the body, well, you're basically giving an instruction to the backend that it needs to delete that data. Now remember, these are just HTTP requests. It is up to the backend to actually act upon them. If you get a delete request in your home-coded API and you don't delete the data, well, that's on you. It's just an easy way to recognize the posts that are coming in and doing with it just based on the request method itself. There are more specific options like connect, options, trace, and patch, but I refer to the Wikipedia for that for more in-depth look. They might not be of use for this course project that we are doing for Web 2, but they might be handy in the future if you need different options. An example of such a request, say that we go to ehb.instructure.com, which is our Canvas environment. This is a request that I made a while back. As you can see, the host, so the get URL, it's a get request that we see on the first line. The host itself is HTTPS, so it's a secure one, and it uses the HTTP protocol. If we go down a bit, you see that the user agent, that these are still headers that are just automatically added by my browser, and my browser would be Mozilla that I would be using. If we go further down, we see the accept, we see accept encoding and accept language. Those are standard headers that are added to it, as in I accept back text HTML, application HTML, etc. for that. Now also very important to know, my PC at that point stood in Netherlands, in Dutch. So as you can see with accept language, it automatically passes along like, hey, this browser is in Dutch. If you have a Dutch version, the backend can respond to that and actually pass along a Dutch version back. Now, the cookie is some data that I have. More importantly, in the cookie, in the previous to last line, log session ID, that it tells it that I was already logged in to Canvas. So that ID alone was stored on my browser. It passes along automatically if I serve to instructure.com. And then it says, oh wait, this person was already logged in previously. Let's log him in again if his credentials are still valid. So login session ID and Canvas session are used to log back in and to get started. Now, of course, we made this request. I serve to hb.instructure.com. The next part in the chain would be to get a response. Now, the response can contain, will contain two things, status code and headers. And again, optionally can contain a body with data. So if we were to, again, the same Pokemon example, if we ask for 150 Pokemon, if everything goes correctly, we get back a response with the 150 Pokemon. Now, the status code is something very easy to use. It's something very small, but it has so much power. Just like the request methods, get, post, put, and everything else, the status codes that are passed along with me with the response can automatically tell you if the request succeeded. So we have a couple of different ones. Everything in the hundreds is informational, is that it request received, everything is okay, something has been done, etc., etc. The one we really are looking for is the 200 ones. So 200 means your request was successful. I think 201 is your data has been successfully saved. So you can play with that. There is a whole list online for use cases. If you ever develop a very detailed API, these are the codes you already need to give to your developers who are calling it from the front end, because they automatically know then if something went right or wrong. So the last three are in the 300 series, which is a redirection. If you need to reroute that request to a different server, do something else with it, it can be done. 400 is a client error, mostly because of the request containing either bad syntax, is invalid, so the request is on our side incorrect. And server error is the error in the 500 range, and it mostly says it that the server came across an error, could be not being able to connect to the database, not being able to find the correct ID, maybe bugs in the code of the backend server, and that results in a server error. Now, of course, if we have those status codes, we can send something back from the backend. So our backend is responsible for handling all the requests. It redirects to different pieces of code. So ideally, you would have classes, controllers, something else logging that code. So don't make one file, of course, getting that code. It formats the response as you want. Do you want to send JSON back? Do you want to send HTML back? All those things. And you send it back to the user. Now, all of this, of course, sounds confusing in the beginning. All of this sounds complex to build. Now, of course, we're in the Node ecosystem. We have packages that do stuff for us. So if we want to create an API, instead of building everything from scratch, Express Web Server will handle all those things that I just talked about and then some more. Express. Now, Express is a minimal and flexible Node.js web application framework that provides a robust set of features for web and mobile application. It builds APIs. It can do so in a very easy way and with little code. You can find all the details on expressjs.com. And the latest version there, you can download using npm. You see a familiar command on the bottom there, npm install express. So that means you just create a file on your desktop, script or server.js. You make a package.json. You install express. You follow the getting started guide found here, and you are up and running. That's it for now. So good luck with the exercises. I would suggest start with the Getting Started API, and this is it for the theory. Thanks again for listening.